Hello class, this is Ms. Riggins coming to you with our final day of working with congruent triangles, and we're going to learn something that I have shortened, other math teachers have shortened into CPCTC. Well, first of all, let's go back to our notes and look at what we know about figures that are congruent. If we know that figures are congruent, then we know based off the fact that corresponding parts of congruent figures are congruent, then we know that the corresponding parts are congruent to each other, and that only occurs if you have congruent figures. And so CPCTC stands for corresponding parts of congruent triangles are congruent, which means if I know that two triangles are congruent, then I can show that all pairs of corresponding sides are congruent. Well, why is that important? Well, we're going to have to prove that a pair of corresponding parts are congruent, and in order to do that, we're going to have to show first that they belong to congruent triangles. So let's take out our note-taking guide on page 104. So in example 1 on page 104, we have to prove that the side DC is congruent to side AC. That's what we have to prove. And the information they give us is that angle 1 is congruent to angle 2. And they also give us the information that side AB is congruent to side DE. And they want us to prove again that DC is congruent to AC. Well, in order to prove this, our plan of action is to first prove that the triangles ABC and triangle DEC are congruent. Because if we can prove that triangle ABC is congruent to triangle DEC, then we can match up and know by CPCTC that DC is congruent to AC. So our goal is to first show that the two triangles are congruent. So once we do that, we'll be able to continue on. So sometimes the book tells you to copy down the diagram, but I just marked up the diagram as they gave it to me. If you want to, you can copy it down. And then it says we're going to add the information that we can deduce. So let's take a look over here at angle ABC and angle DEC. So what we can notice about angle ABC, which is this angle, is that angle ABC forms a linear pair with angle 1. And if angle ABC forms a linear pair with angle 1, then that means that the measure of angle ABC plus the measure of angle 1 is equal to 180, or the measure of just angle ABC by itself is equal to 180 minus the measure of angle 1. And what we can also see basically also is that angle DEC forms a linear pair with angle 2, which means simply that the same thing, that if I add up the measures of angles DEC and measure of angle 2, I'm going to get 180 degrees, which means the measure of angle 2 actually is equal to the measure of angle DEC is equal to 180 minus the measure of angle 2. But remember, we also know that the angle 1 is congruent to angle 2. And since angle 1 is congruent to angle 2, then I can replace this with 180 minus measure of angle 1. In other words, the measure of angle DEC is also equal to 180 minus the measure of angle 1. And the measure of angle ABC is also equal to 180 minus the measure of angle 1. So that means that since angles ABC and DEC are supplementary to congruent angles, that these two angles themselves must also be congruent toward each other because they have the same angle measurement. Okay? So far we have another pair of corresponding angles as being congruent. There's also another pair of angles that are congruent, and it may not have been given to us, but it's obvious because we know that they form a very special angle pair in geometry. If we look at angle ACB and angle DCE, you notice that they are a pair of vertical angles, so therefore we know that they are also congruent. So now we have, based off of our markings, we have two pairs of corresponding angles of the triangle that are congruent, and we have one pair of corresponding sides that are congruent. So therefore we can use which triangle shortcut to prove congruence? If you said that we can use the triangle shortcut of angle, angle, side, you'd be absolutely correct, okay? Instead of angle, side, angle. Because as you can see based off the markings, this is angle, angle, side. And since we can use angle, angle, side to prove that the two triangles are congruent, then we know by CPCTC that the corresponding parts are also congruent. So therefore DC is congruent to AC, and the reason being is CPCTC. And that's all.